I wanted to finish out the example that we started with. So here we got some DVD bonus material for the first example, since I was talking too much and I ran out of time. So if you would recall, we had finished the pivots in column 1 and column 2, but column 3 could not be a pivot column because I couldn't put a 1 in the third row, third column, without breaking the zeros that we worked so hard for in the first two columns. If I try to move this 2 down, then I lose the 0 in the third row, second column. If I try to move the -3 down, then I lose the zeros that I worked so hard for in the third row, first column. So instead of trying to make a pivot in the third column, I just moved to the third row, fourth column and try to pivot there. In this case, I look down below, and if I move the -5 up into the third row, if I switch row 4 and row 3, I can put a 1 in the third row, fourth column, and so that's where we're going to make our next pivot. I'm just going to do -1/5 times row 4 and put that into row 3, and so now I have a pivot in the fourth column. The last thing we need to do is use that 1 to zero out the rest of the column. So I'm just going to do -3 row 1. I didn't leave space. I forgot what color I left off on. That's fine. I'm just going to do -3 times row 1 and add, row 3, and add that to row 1 and make that my new row 1. So my new row 1 will look like 1, 0, -3. Now notice that these 3 zeros did not change the first 3 columns in row 1. That's what we want. But -3 row 1 plus row 3 will zero out where we're not pivoting in column 4. And also, this is kind of uninteresting, but 0 and 5 is 5. I also need to do a pivot to get rid of the -3 in the second row, fourth column. So I'll just do 3 times row 3 plus row 2 and make that my new row 2. So 0 and 0 is 0, 0 and 1 is 1, 0 and 2 is 2, 3 minus 3 is 0, and 0 minus 3 is still -3. My third row can stay 0, 0, 0, 1, 0, and my last row can stay 0, 0, 0, 0, 0. So I had a pivot in the first row, first column, in the second row, second column, and my next pivot was in the third row, fourth column. Each pivot column has a 1 in the pivot position and zeros everywhere else. So this is the reduced row echelon form. So here, now we have reduced row echelon form. All the rows of zeros at the bottom. Each pivot column has a 1 in the pivot position and zeros everywhere else. Let's write down the corresponding linear system for this augmented matrix. So pulling out of augmented matrix and writing down the corresponding linear system, we've eliminated a lot of the variables. So here we have x1 minus 3x3 is equal to 5. The second row corresponds to x2 plus 2x3 is equal to -3. x3 is just x3, and this third row corresponds to x4 equals 0. We need to want to take this information and write the general solution. Notice that the pivot columns x1, x2 correspond to x1, x2, and x4. So there's a pivot there, there's a pivot corresponding to this x2, and there's a pivot corresponding to this x4. There was not a pivot in the x3 column. So the variables x1, x2, and x4 that correspond to pivot columns are called basic variables. Variables that correspond to pivot columns are basic variables. The variables corresponding to pivot columns are the basic variables. Variables corresponding to non-pivot columns are called free variables. What we want to do is write the general solution. We want to be able to write essentially a formula for how to write a solution set to the linear system. To write the general solution, we solve for the basic variables in terms of the free variables. To get the general solution, solve for the basic variables in terms of the free variables. To write the general solution, we're going to write the basic variables in terms of the free variables. So I'm going to write x1. I'm going to take that first equation. I'm going to say x1 is equal to 5 plus 3x3. I'm going to write an equation for x2. x2 is going to be negative 3 minus 2x3. I'm going to make a note that x3 is free, even though we can see that x3 is a free variable because it's x1 and x2 are written in those terms. And the last part is saying that x4 is equal to 0. So this is the general solution. Right now, because we're new at this, I need you to write x3 equals free. I need to write x1, x2, x3, and x4 for each of the variables. I need you to note that x3 is free. This is because we're new. Later on, you can just write the x3s here and x4 is equal to 0 and imply that x3 is a free variable. But you don't get to make that implication yet until I know that you understand that x3 is a free variable, and we write the basic variables in terms of the free variables. So for now, you have to write x3 is free in your general solution. So this is the general solution. Now what we have is a roadmap for how to write a solution to this system of equations. For every value of x3, we get a different solution to the original system. If x3 is equal to 0, then 5, negative 3, 0, 0 is a solution. If x3 is equal to 10, then 35, negative 23, 10, 0 is a solution to the original system. For every value of x3, we get a different solution to the original system. For every value of x3, we get a solution to the system. So since we have a free variable, that means we're going to have infinitely many solutions, because for every value of x3, we get a different solution to the original system. In this case, we've got a solution to the system that has one free variable. And so that the general solution is our description of the solution set to the original system that we had before. All right, that's all I wanted to cover in this supplemental video. I wanted to finish out that the row operations to get the reduced row echelon form, and I wanted to translate the reduced row echelon form to the general solution. All right, that's going to do it for this supplemental video. I'll see you all on Wednesday, and thanks for playing.